Hello students, hope you're doing fine. So in this video we are handling the rates of change, and before we handle the rates of change, let's make an introduction into the chain rule. What do we ought to know? If I have a function y, if y is a differentiable function, if y is a differentiable function, a differentiable, if it is a differentiable function of maybe two variables of t and x, and if I have there x, if x is still a differentiable function of t, then y is a differentiable function of both t and x. You're there. Y is a differentiable function of both, of a combination of both t and x. In other words, if I'm differentiating y with respect to x, then it means since y is differentiable with respect to both with t, it can be differentiated with respect to x and then with t, then t is a differentiable function of x here. Then it means that dy dx is equal to dy dt multiplied by dt dx. And mathematically it's like I've not changed anything, because this and this can still go away, dt and dt, and I go back to dy dx. Just an introduction. Separate these guys, introduce a dt times dt. It's like introducing a dt times dt, which can cancel. More like such a format. I have dy dx, then I introduce here a dt by dt, a dt by dt, because this is multiplication. These guys can alternate their signs. This one, their places. This one can come this way, the other one goes this way, so that I come up with such an algorithm. So the proof for the chain rule, that one you can look it up in the books you are using, maybe the BS, the Backhouse and Tranta, and maybe Understanding Mathematics. You're understanding pure math, all those can help you get the proof. So we can look at how we apply the chain rule. So some examples. So we have there that our first example, using the chain rule, differentiate y is equal to x plus this guy squared. So what we do is we can let this one be anything. So if I can let maybe a t to equal to x plus 2, such that my y, in the place where I have x plus 2, I'm putting there t, y is now t squared. You're there. Such that now my dt with respect to x, this guy is equal to a 1. Then my dy dt is equal to a 2t. If y is equal to this, I'm differentiating y with respect to t is 2t. So that now applying the chain rule, dy dt dy dx is equal to dy dt multiplied by dt dx. I have dy dt is 2t into dt dx is 1, which is the same as a 2 into t. I have here t, which is x plus 2, which is x plus 2. That is how we differentiate. That's how we differentiate by the chain rule. So without wasting space, let us economize here a bit. A bit, and we put our question 2. Maybe let us choose a number that is a bit, y is equal maybe to x cubed plus maybe 10, then maybe power 5. Such a good number. This one is a nice one, a bit somehow at least. So I can still let, if I let t equal to what is inside the brackets, x cubed plus 10, so that my y will equal to t power 5, such that I have dt dx, this guy is going to equal to 3x squared. If I differentiate this guy with respect to dt with respect to x, so that dy dt will equal to, lower this guy down, reduce the power by 1 power 4, so that I have now my dy dx dy dx as equal to dy dt multiplied by dt dx. If you multiply that guy by dt dx, so you have dy dt is this guy, which is 5t power 4. This is 5t power 4 multiplied by dt dx dt dx, I have it there at 3x squared. So this guy is 3x squared. I have this as 3x squared as the dt dx. So I put in this bracket, I have this guy as a 15x squared into, I have here a t power 4, but I know my t is x cubed plus 10. So this is x cubed plus 10, and then this guy is raised to power 4. As simple as that. And then this obeys the rule of direct differentiation, which says lower down the power, which is 5, lower down the power, which is going to be a 5, then reduce it by 1, which is 4. You're there. Then multiplied by the differentiation of what is inside the brackets, which is going to be a 3x squared. 3x squared multiplied by a 5 that I've dropped is 15x squared, the bracket x cubed plus 10, then raised to power 4. So student, first master that, and then in our next video let's handle the rates of change. But we say that we are not being selfish, we are passing together. Inform a friend, tell a friend, tell a friend. And then remember to subscribe to our channel, and then like our videos, hit the notification button such that we can create more mathematical and interesting concepts like this.